Today's science lesson is called the Let's Bounce Lab. In this experiment, we will be observing how kinetic energy can move from one object, transfer through a second object, and affect the motion of a third object. So we're going to watch how kinetic energy, which remember is just the energy of motion or the energy of movement, how the energy of one object moving can make contact with a second object and then actually transfer that kinetic energy through the second object into a third or fourth or even fifth and sixth object. So remember, today's lab is called Let's Bounce. So let's make sure we have the correct papers and get started. Today's lab is actually going to take place over 2 pages. All right, we're going to do a series of trials, and this experiment is going to be broken into 3 parts. So let's start with part 1. Just some pretty standard questions here. Part 1, number 1. Why don't you go ahead and answer number 1, number 2, number 3. Pause the video, get those answers down, and press play when you're ready to continue. So, what is potential energy? Well, your answer should be something along the lines of potential energy is the energy of something that is not moving or at rest or not in motion or being still. This answer should explain that potential energy is the energy of something that is not in motion but has the potential to move later. It's not moving now, but it can move at a later point. Number 2, what is kinetic energy? This should say something along the lines of that kinetic energy is just the energy of something that is moving or something that is in motion. Describe a situation, number 3, describe a situation in which potential energy is converted, changed to kinetic energy. The previous lab that we did focused on how things transfer from potential to kinetic energy. But really, any scenario that you describe where something has potential energy, is still or at rest, and then begins moving, showing kinetic energy, will be a good answer here. So just describe any scenario where something has potential energy, is at rest, and then begins moving to show kinetic energy. Part 2, this is where our experiment is actually going to begin. So we're going to place pinto beans, a pencil, a rubber eraser, and a rock on top of a table. What I want you to do right now is in this table, in this chart right here, I want you to do step 2. Predict what will happen to the objects on the table when you drop a golf ball, a baseball, and a basketball near them. Record your predictions in the table. So, if I have a pencil, rubber eraser, a rock, and some pinto beans on a table, and I drop a golf ball near them, what will happen to the objects? Will they move? Will they not move? They'll move a little. They'll move a lot. They'll move up. They'll move down. Record your prediction here. Then predict what will happen when I do the same thing with a baseball. What will happen to those objects if we drop a baseball onto the table near them? Third, predict what will happen when we drop a basketball on those items. When we drop a basketball, what will happen to the items on the table if we drop a basketball near them but not actually on them? All right, when you have your predictions completed, go ahead and press play, and we will move into the trials. Now, as we go into the trials, there will be a label telling you what trial, what ball, and what trial we're on. So make sure you are pausing the video to record observations at the end of each trial. Pause the video, rewind it as much as you need to, because in these boxes, you must have the observations that you saw in the video. So when I drop the golf ball for trial 1, you need to describe how the objects moved. You could be telling me how they moved. You can tell me which ones moved. You need to tell me if none of them moved, or maybe a couple moved and a couple didn't. Or maybe one moved a lot and three of them didn't move at all. Or maybe they all moved a little bit. Maybe the pencil moved and the eraser didn't. Maybe the pinto beans moved and the rock didn't. Whatever you observe, whatever moves, doesn't move, if it moves a lot, if it moves a little, if it moves up, if it moves down, whichever one, whatever you see happen, you need to make sure you are recording that in these spaces. They don't have to be complete sentences, but you do have to have your observations recorded. So continue the video, and we will come back to our page after the chart, after all the trials have been run. Golf ball trial 1 in 3, 2, 1. Record your observations. Pause the video if you need to. Write down what moved, or just as importantly, what didn't move. Golf ball trial 2 in 3, 2, 1. Pause the video. Record what moved, what didn't move. If something did move, tell me how much. Golf ball trial 3 in 3, 2, 1. Pause the video. Be sure to record your observations, what moved, what didn't, how much did it move, which way did it move. And when you're ready, press play for the baseball trials. Baseball trial 1 in 3, 2, 1. Record your observations. Baseball trial 2 in 3, 2, 1. Pause the video, record your observations. Baseball trial 3 in 3, 2, 1. All right, pause the video, record what moved, complete your observations for the baseball trial. Press play when you're ready for the basketball trials. All right, basketball trial 1 in 3, 2, 1. Pause the video, record your observations. Basketball trial 2 in 3, 2, 1. Pause the video, record your observations. Basketball trial 3 in 3, 2, 1. Pause the video, record your observations. Now, to finish up part 2, we have one more question we need to answer. This question says, which falling ball transferred the most kinetic energy to the objects around it? Why do you think that is? Were your predictions correct? Well, first we need to see how many question marks do we see in this question. There's 1, there's 2, there's 3. If we have 3 question marks, that means we need 3 parts to this answer. So, using your observations, look back at your chart and decide which falling ball transferred the most kinetic energy to the objects around it. Did the golf ball, baseball, or basketball cause the objects on the table to move the most? Which one caused them to move the most? The next part of your answer, why do you think that is? Why do you think that ball caused the most kinetic movement? And lastly, were your predictions correct? Part 2. We need 2 questions we need answered. What is a non-contact force? Give an example. What is a contact force? Give an example. Pause the video, answer these, press play when you're ready. So, number 1, what is a non-contact force? Well, non-contact means not touching. So a non-contact force is something that can apply a force without actually touching the thing that is applying its force on. What is an example of this? Gravity is a non-contact force. Gravity is constantly pulling us towards the center of the earth, but gravity is not actually reaching up and touching us. Gravity is a non-contact force. Any other examples of non-contact force? Magnetism is another one, right? We can put 2 magnets. If we get 2 magnets really close together, can you feel them pushing or pulling? Absolutely, but they aren't actually touching yet, right? So magnetism can be another non-contact force. Number 2, what is a contact force? Well, if a non-contact force has something that can apply force to an object without touching it, then a contact force is going to be the opposite of that. Something that has to be touching an object to apply force to it. Give an example. Well, we humans have to apply a contact force. If I want to make this pencil move, I need to be in contact with it. I cannot move this pencil without touching it, right? I'm not touching this pencil, I can't move it. So I can only apply a contact force where I have to physically touch the pencil before it will move. Another good example of this that's very important to know is friction. Friction is a contact force that works against motion. Now we're ready to do the final part of our lab today. This part of the lab will be done very similar to the first parts of the lab we did, where we tested and observed the golf ball, the baseball, and the basketball. This time we are going to be observing the effects of a non-contact force like gravity has on kinetic energy, the transfer of kinetic energy, and compare it to how a compact force like a push, what effect that would have on the transfer of kinetic energy. We will do this in a similar way. We'll have the same items, pencil, eraser, pinto beans, and rock. They will be placed in the same positions on the desk as we did before. For both of these, we will be using the basketball that we used. So let's take a second and talk about what the difference in the non-contact force trials will look compared to how the compact force trials will look. So bring your head up for just a second. This is our basketball. When we are doing the non-contact force, we are going to let gravity accelerate this ball. We're going to let gravity accelerate this ball down onto the table. So what I mean by that is I'm going to hold the ball up. I'm not going to push it. I'm not going to pull it. I'm not going to throw it. All I'm going to do is release it. Okay? We are going to let gravity apply force. We are going to let gravity, a non-contact force, pull this ball down. I am not putting any more force into it at all. Now, in contrast, for the contact force, where it says push, the only difference, I'll hold the ball, same ball, I'll hold it at the same height. The only difference is when I drop the ball, it is not going to be just gravity. I'm also going to use my hand and give it a little bit of a push, right? So gravity is going to be pulling it down, but I'm also going to be applying a contact force and in the form of a push from my hand, pushing the ball down. So this should increase the speed that the ball falls. So it'll look like this. 3, 2, 1. See? So non-contact force, when I drop it, I'll just let it go. For the contact force, when I drop it, I'm going to use my hand and push it down a little. All right. When you're ready, you may move along to the trials. One thing you need to make sure you do is we need to make a prediction, okay? Now, when I was doing the non-contact force and we were letting gravity pull the ball down, what is your prediction of how that non-contact force will affect the kinetic energy of the items on the table? Once you make that prediction, come down and think how the contact force, the push, how will this force affect the items on the table? Make that prediction, and then we'll move along to our trials. Non-contact force, trial 1, 3, 2, 1. Pause the video, record your observations. Non-contact force, trial 2, in 3, 2, 1. Pause the video, record your observations. Non-contact force, trial 3, in 3, 2, 1. Pause the video, record your observations. Remember, you're observing what moved, where it moved, and how it moved. You're also telling me what didn't move. Pause the video and play it when you're ready for the contact force trials. Contact force, trial 1 in 3, 2, 1. Pause the video, record your observations. Contact force trial 2 in 3, 2, 1. Pause the video, record your observations. Contact force trial 3 in 3, 2, 1. Pause the video, record your observations. And lastly, now that we have our chart filled out, just one last question. Which type of force affected the objects the most? How do you know? 2 question marks, so we need 2 parts of these answers. So, which type of force affected the object the most? Contact, non-contact, or contact force? Which one caused the most kinetic energy? And how do you know? Right? Using information in what you observed, how do you know that that specific force caused more kinetic energy? All right, make sure you get all of this answered on both sides. Make sure your charts are complete, and good job. See y'all later.